Yes, friends, welcome once again to the class. And before I move on to refraction matrix, I would like to tell you one thing that never trust any political party blindly. Okay, I would say that never trust any political party blindly because nowadays this culture is developed that people are trusting their favorite party blindly. Okay, so do not trust any political party blindly because almost 99.999% 99.999% politicians are not there for social service. Okay, no one wants to do social service in politics. Everyone is for their own benefit. They are getting 3-4 pensions. If they win 3 or 4 elections, then they are getting 3 or 4 pensions for it, for that. Okay, so 99.999% politicians are not there in politics for social service. Okay, they want that they are privileged. They get a lot of privileges because of being an MP or MLA. That's why they are going into politics. Okay, and also the money factor is also there. It also drives them into politics. Okay, so never trust any politician or political party blindly, no matter whatever good it has done to you. But you should never trust the party, your favorite party, blindly. You should always ask the question. Okay, so refraction matrix we will learn. So refraction matrix basically represents the effect of refraction. Okay, now this is your lens. This is what your refracting surface. Okay, this xy is your refracting surface. Now in this refracting surface, the thing is that this is your center of curvature. Center of curvature of this is spherical surface. Means if we complete the circle of this spherical surface, then the center of this circle will lie at C. So that's why C is its center of curvature. And you know this very well that a line drawn from the center of curvature to the surface of the refracting entity, a line drawn from the center of curvature to the surface of the refracting surface, to the line, to the boundary of the refracting surface, that is basically normal. So Cn will be your normal over here. Cn will be what? Cn will be your normal. Okay, so Cn is your normal to the spherical surface. Spherical surface means this surface, okay, which is basically convex in nature as shown over here. Okay, so AD is your incident ray. AD is what? Your incident ray. And your DB is your refracted ray. Okay, AD is your incident ray and DB is your refracted ray. And this is your CDN is your normal, and angle ADN. What is angle ADN? Angle ADN is equal to your incidence angle. Angle ADN is your incidence angle. Okay, you can clearly see this thing, that the angle which the incident ray makes with the normal, that is basically your I. Okay, and angle which the refracted ray makes with the normal, it is called as your refraction angle R. Okay, so angle of incidence, and this is your angle of incidence I, and this is your angle of refraction R, because they are being measured from this normal CDN. Okay, they are being measured from this normal CDN. Got it? Now this particular angle, this particular line z dash z, okay, this is your z dash z. This particular line, this dotted line, has been drawn parallel to this z axis. Why it has been drawn parallel to this z axis? So that we can take the geometrical considerations into account. That's why this z dash z has been drawn parallel to this z axis. As soon as I draw it to be parallel to z axis, I will assume two angles to be present over here. This will be your alpha 1, this will be your phi 1, let us assume, and let this be your phi 1 and let this be your alpha 2. So clearly this why these two are phi 1 only, why this is phi 1, so why not this is why it is not phi 2? Okay, why it's not phi 2, why it's phi 1 only? So you will understand this thing from here, that these are vertically opposite angles, these are vertically opposite angles. So this is your straight line and this is also a straight line, so these two are vertically opposite angle. Okay, but these are not vertically opposite, which this and these are not vertically opposite, because the ray has refracted from here. Refracted means it has changed its paths. So this ADB is not a straight line, it is not a straight line. Okay, ADB is not a straight line. So that's why alpha 1 and alpha 2 will not be equal, but your phi 1 will be equal to this, means your angle z dash dn, angle z dash dn is equal to your angle z dash dn is equal to your angle CDZ. Okay, angle CDZ. So these two are equal angles, angle z dash dn and angle CDZ. These are basically your equal angles because they are vertically opposite. But these two are not vertically opposite. Which two? Angle ADZ dash is not equal to angle BDZ. Okay, these two are not equal. Why these two are not equal? Because they are not vertically opposite, because this ADB is not a straight line. ADB is not a straight line. That's why these two angles are not equal, and they have been named as alpha 1 and alpha 2 instead. Okay, and this particular ray AD is your paraxial ray also. You must remember this thing, that all these formulas, this whole matrix method will only be applied in case of all these paraxial rays only will comprise of the matrix method, because matrix method in case of the non-paraxial rays. Okay, suppose I have a ray very far apart, so suppose this AD is not paraxial, suppose, then what will happen? If AD is not paraxial now, then this whole thing becomes very complicated. The matrix operations will become very complicated if AD is not your paraxial. Okay, so the matrix which will come, that will be very complicated. So those complicated matrices we can't deal with them. Okay, we can't deal with them. So that's why in order to simplify our work, we have basically taken paraxial rays, so that the matrices which we get as a result of these paraxial rays are very simple in nature. So that's why we have taken paraxial rays. Okay, so that's the thing which you must take care about. Okay, so refraction matrix represents the effect of refraction. Do you got this? Refraction matrix represents what? It represents the effect of refraction. Okay, so yes friends, there was a break because of some issue at my end. Okay, so don't worry. Someone was asking that I am feeling very lonely in Delhi. Okay, I am feeling very lonely in Delhi, and I am also feeling very pessimistic. Okay, I am also feeling very pessimistic. So I am heartbroken also, and nothing is going on good in my life. Someone was saying like that on WhatsApp. Someone had messaged me. So I would say that listen to songs, and while studying, just put on songs in the background. Okay, so I can just listen to Delhi Belly songs. Okay, listen to Delhi Belly songs. Okay, so these songs are basically helpful if you are in depression. But the thing is that only if you are okay with profane language, then it's okay. These songs are okay for you if you are okay with profane language. If you are okay with that, then Delhi Belly songs are best for you. if you are a depressed person in Delhi. Okay, so refraction matrix. Refraction matrix represents the effect of refraction. Okay, as already told to you that this AD is your, those songs can be played in repeatable mode also. Okay, so those may help you if you are completely lost in Delhi. So AD is your incident ray and DB is your refracted ray. Okay, and CDN is your normal. CDN is what? CDN is your normal. This is your angle of incidence as already told to you, because as this is the incident ray and this is the normal, so this will be your incidence angle, angle of incidence, and this is your refracted ray and this is your normal, so this will be angle of refraction. Okay, so this also I already told to you. And this AD is a paraxial ray, that's why this PP dash, this will be almost P and P dash will P and P1 will almost coincide. This P1 and P will almost coincide because this AD is a paraxial ray. So we will go into all those aspects, but before that let's see. XY is a convex spherical refracting surface of radius of curvature capital R. This is your radius of curvature measured from the pole till the center of curvature. This is what? This is your radius of curvature. Okay, all songs are good in it, no song is boring by the way, but there are only 2-3 songs which are helpful for a depressed person. Other songs are just like that. Okay, so you can download the songs and enjoy them, but those are only good if you are okay with profane language. Only then those songs are good. Okay, so XY is a convex spherical refracting surface of radius of curvature R. This is your radius of curvature R, separating two media of indices N1 and N2. Two media of indices N1. Suppose over here the refraction, the medium has a refractive index N1, and over here in this area the medium has refractive index N2. Then what happens is that your N2 is clearly greater than N1. Okay, your N2 is clearly greater than N1, suppose. Okay, let us suppose such a situation is there, as written over here. XY is convex spherical refracting surface of radius of curvature capital R, separating two media of indices N1 and N2, where N2 is your greater than N1, C being the center of curvature, I and R be the angle of incidence and refraction respectively. As I already told to you that I and R are angle of incidence and refraction respectively. Now by Snell's law. Now what do we get by Snell's law? Just have a look over here. N1 sin I will be equal to your N2 sin R. How? By Snell's law, which you have already learnt in your 10th standard. So by Snell's law we get something of this kind. Now you know this very well that these are paraxial rays. This AD has been shown like this, but in reality it is very close to the axis. Okay, this ray AD is very close to the axis Z. Okay, then only it will be called as paraxial ray. So this D will be somewhere over here, and this line will be something like this. Okay, so it will be a very small angle. So in that condition, this angle of incidence will also be small in that case, and this angle of refraction, as the angle of incidence will be small, so angle of refraction will also be very small in that case. So what happens is that eventually your sin I and sin R, when measured in when I and R are measured in radians, then sin I can be written as simply I, and sin R can be written as simply R in case of your what? In case of your small angle in radians, and as AD is paraxial, so I and R will be also small. Okay, so I can eventually write like this: N1 I is equal to N2 R. Okay, this is your equation number 1. Okay, I and R being small, so N1 I equal to N2 R. This is your equation number 1. From figure what do we get? I equal to this much and R equal to this much. This is from the figure. Now how do we see at the figure? This is your I, from here till here, this is your I, and this will be equal to alpha 1. I will be equal to, from the figure clearly, alpha 1 plus phi 1. Okay, and R over here you can see that R will be equal to your alpha 2 plus phi 1. Now how phi 1 and phi 2 are equal, I have already told to you. Okay, how these two angles are vertically opposite, that's why both are phi 1. I already told to you. These both are equal because both are vertically opposite. Already told to you in the previous segment. So I equal to phi 1 alpha 1 and R equal to phi 1 plus alpha 2. From figure we can see this clearly. Now you know this very well that we had got N1I is equal to your N2R, which is the thing which we had got. So put the value of I from here over here and put the value of R from here over here. Then what will happen? Then what will happen is that this thing will come, and N1 alpha 1 and all this stuff, you can look at this clearly. All these are simple mathematical manipulations, that's it, nothing big in it. So finally you get something like this. Now the phi 1 value, how it has been put as x by r, how phi 1 has been put as x by r. So you will have to look at this thing, that phi 1 is equal to 10 phi 1 and 10 phi 1 is equal to your x by r. So we have done reverse substitution over here. You know this very well that up to now what we used to do, up to now we used to take time, substitute tan phi 1 equal to phi 1 when phi 1 is very small. Okay, so at that time we used to write that tan phi 1 equal to phi 1. But over here we are doing the reverse thing. What thing we have done is that I have skipped one step over here. There is one more step over here. N1 alpha 1 minus N2 minus N1 tan phi 1. You can write this phi 1 as tan phi 1 over here. And as soon as you write like that, this tan phi 1 can again be written. How can it be written? You will have to go into the geometry of figure and you will realize that this tan phi 1 can be written as x by capital R. Now how? Let's see how. Tan phi 1 you can see from here. Tan phi 1, when we write, this triangle will come into picture. So it will be x by P1C. It will be x by P1C. But you know this very well that this P1 and P almost coincide because this is a paraxial ray. So P and P1 almost coincide. So that's why instead of writing x by P1C, I will write x by R directly as the value of tan phi. Okay, tan phi value, you can look at the triangle. Have a look at the triangle DP1C. Have a look at the triangle DP1C. As soon as you look at the triangle DP1C, you will see that tan phi 1 is equal to x by, means dp1 by p1c is the value of tan phi 1. What is the value of tan phi 1? This divided by this. But you know this very well that your p and p1 coincide almost because AD is a paraxial ray. So it will be equal to x by r. So your tan phi 1 value is equal to your x by r. Okay. So tan phi 1 is equal to x by r. Now you know this very well that n2 alpha 2 is equal to your lambda 2 and n1 alpha 1 is equal to your lambda 1. How did we get this? How did we get these values of lambda 1 and lambda 2? So in order to have a look at that, you should go to the previous class. In the previous class, I had already told to you in the previous class that when we try to write in terms of the alpha coordinates in terms of lambda, then the conversions are like this, that lambda, for example, you convert from Cartesian to polar, right? in the same manner, either you convert from Cartesian to polar or from polar to Cartesian, like that. So similarly the conversions are like this. Now in polar to Cartesian, the conversions are like this: r cos theta y equal to r sin theta. These are the conversions when converting from Cartesian to polar. But in our case we are converting from alpha 1 to lambda 1. So the conversions are over here, that lambda 1 is equal to n1 alpha 1 and lambda 2 is equal to n2 alpha 2. Okay, these are your conversions. So just apply the conversions over here. In place of n1 alpha 1, as already derived in the previous class, it is equal to lambda 1. n2 alpha 2 is equal to your lambda 2. So those things you have substituted over here. Now your this value, this particular value, n2 minus n1 divided by r is equal to your p. Okay, means power of the refracting surface. It is from the definition of power. Okay, how this whole entity has come out to be equal to p, that is from the definition of a refracting surface. It is from the definition of a refracting surface. So power is equal to n2 minus n1 divided by r is equal to power of the refracting surface. So you will substitute in the place of n2 minus n1 by r the value equal to p. So you substituted that, and let this be your equation number 2. And also x2 is equal to x1 is equal to your x. Now this is a point worth understanding. X1 is equal to x2 is equal to x. How it has come? You know this very well, that this ray has refracted from this particular point D and it has gone. Okay, although it is looking almost straight over here, but it is not straight. It is not straight. Okay, AD has gone like this and then it has tilted over here at point D. It has tilted. It has tilted towards the normal because N2 is denser medium, right? N2 is denser medium. This medium is denser, and this medium is rarer. Okay, so whenever light ray travels from rarer medium to denser medium, then it bends towards the normal. It bends towards the normal, and this is your normal. So it has bent towards the normal. Okay, it has bent towards the normal. So dB has been bent. AD ray was incident and dB ray has got refracted. So dB is your bent towards the normal. Okay, now your this thing, this AD will be equal to, this thing will be equal to, for incident ray the value of x for incident ray AD. So D point is common between the incident ray AD and refracted ray dB. D point is common between incident ray AD and refracted ray dB. So at this particular point D we have x with us. So for AD consider the distance to be x1. For dB consider the distance to be x2. Okay, but these x2 and x1 are same, duplicate. Okay, if you have watched the previous class, then over here we have taken x1 and x2 as the two coordinates over here. Okay, over here what we have done is that we have taken x1 and x2 as the two coordinates, but over there in the case of refraction, there was a refracting surface over here. So as there was a refracting surface over here, so this point was common between this medium and this medium as it lied on the surface. So x1 and x2 have become common in our case, and that is equal to x basically. Okay, so let's see. So it is equal to x. So your x2 equal to x1 equal to x, as you can see from here. Okay, and since the height of the ray before and after refraction at D is the same, okay, height of the ray before and after refraction in D is the same, as D is the common point. So the matrix for the refracted ray may be written as, now how we have written this, just have a look at this. Okay, just look over here that your this is x, right? So your x2 is equal to what? X2 is equal to your, now let us consider this to be x1 for just an instance. just an instance, because x2 is equal to x1 is equal to x. So for our simplicity, in order to write equation, you substitute this x by x1. Then what will happen? Your lambda 2 is clearly equal to lambda 1 minus p x1. Okay, this is your lambda 2. And what is your x2? x2 will be your 0 lambda 1 plus 1 x1. This is the value of your x2. Now how to write these two equations in the matrix form? So this by this will come, then what will come? This by this means lambda 2 by x2 has come out to be equal to what? Coefficient of this, that is 1, coefficient of this, that is minus p, coefficient of this, that is 0, coefficient of this, that is 1. Okay, so these things have come. Then lambda 1 and x1 are there, so over here also lambda 1 and x1 will come. Okay, so that is the thing which has been written over here. I hope you understand how to write matrix with the help of equations. You have learned this in your lower classes, you might have forgotten, but about this I have already told to you in the previous class. Okay, about this I have already told to you in previous class. So lambda 2 x2 is equal to 1 minus p 0 1 lambda 1 x1. This is suppose your equation number 3. Now when you try to break the equation 3 into equations, this matrix equation 3, when you try to break it into linear equations, then what will happen? What will happen is that you will first of all write lambda 2. So lambda 2 written equal to sign you will put. Then you will multiply this by this. Then what will happen? This multiplied by this will happen first. So lambda 1 will come. Then this multiplied by this will happen. So minus p x1 will come. So this is your first equation you got like this. Okay. Then second equation x2 is equal to, okay, then this multiplied by this will happen. So what will be the result? 0 into this much means 0 plus 1 into x1. Okay, 1 into x1. So what has come out to be? It has come out to be x1. Okay, so when you go back from the matrices to the equation, then also you can cross verify whether you have written correct thing or not. Okay, so I am telling you a basic simple trick for this, that what you have to do is that suppose you have equations of this kind, y1 equal to m1 x1 plus m2 x2. Suppose you have equation like this, and you have another equation y2 equal to m1 x1 m3 x1 plus m4 x4. You have m4 x2. Okay, just a second. Suppose you have one equation y1 equal to m1 x1 plus m2 x2. This is your equation 1, and this is your equation 2. y2 is equal to your m3 x1 plus m4 x2. These are suppose your equations. Then what will you do? First of all, left hand side write like this, one below the other. Okay, then what are you seeing one below the other? These coefficients 1 2 3 and 4. Okay, so just write them like this. Okay, in the same sequence as they are shown over here. Then two variables are there, x1 and x2 on the right hand side, so just write them like this, x1 and x2. Okay, so this is the format in which you will write them. Now this is your equation number 3. Thus the effect or process of refraction is given by 2 cross 2 matrix. Okay, now you know this very well, that we can understand this thing very well, that this is your lambda 1 x1 corresponds to what? Lambda 1 x1 corresponds to your incident ray. This corresponds to your incident ray, and this corresponds to your refracted ray. This corresponds to what? Refracted ray. Now as this matrix has been multiplied, so clearly the matrix this matrix 1 0 minus p1, this matrix converts the incident ray lambda 1 x1 into the refracted ray lambda 2 x2. So when we, as soon as we multiply it by this matrix 1 minus p 0 1, the incident ray gets converted into the refracted ray. Okay, so this is your matrix of refraction. Okay, so R is known as your it has been shown by R. Why? Because it is your refraction matrix, so that's why it has been shown by R. R is known as your then this is a 2 cross 2 matrix because 2 rows are there and 2 columns are there, so clearly it is 2 cross 2 matrix. Okay, R is known as refraction matrix. R transforms the incident ray lambda 1 x1 into refracted ray lambda 2 x2 during refraction at the surface at point D, as shown in the figure which you might have drawn in your notebook. It is obvious that when we try to find out the determinant of these, what will happen? Instead of brackets we have straight lines, and as soon as we have straight lines, the straight lines are like this, and this multiplied by this minus this multiplied by this, so 1 into 1 minus 0 into minus p, so it is equal to 1. So determinant of R has come out to be equal to your 1. Okay, so determinant of R is 1. So in this way your refraction matrix is also completed. Okay, so hopefully you might have enjoyed the class. And one more thing guys, these all stuff on WhatsApp, never ever read all those stuff on WhatsApp. All bakwas things are going on in WhatsApp. People are fighting with each other, and all those things are going on in social media. So never ever take any attention, never ever pay any attention to all such stuffs. Such skirmishes are taking place everywhere on the media. Okay, so never do anything. Okay, never ever try to take any side of anyone, and just keep on writing the comments and abusing others, and then the person whom you have abused, he will reply in abuses, then you will again reply to him. All these are waste of time. IAS officers never do all this stuff. Okay.